Does the thought of a journey to the stars bring to mind gleaming engines and swift ships? You're wrong, utterly. The hardest part of getting to the nearest star isn't rocket physics. The real problem is human, because even with our fastest spacecraft, the journey would take a full 73,000 years. That's why scientists are aiming for 10% of the speed of light, but even that means a lifetime of 42 years. To date, the record for continuous time in space is just 437 days, an impossible duration for this journey. But what's truly shocking isn't these numbers. It's the 0% chance of coming back. If you too are curious about what a human mind would become, locked in a can for 40 years, then like this video and subscribe to the channel. Because every belief you have about space travel is about to be shattered. From the ground up, we're beginning. For years, we thought interstellar travel was about gleaming engines, clean corridors. We imagined arriving at our destination as if it were an airport. Science fiction always told us this story because its technology seemed like the hardest part. They always told us the equation was a physics problem. But that is not true. That is the greatest lie we have been told, because the real obstacle to reaching the nearest star is not the slowness of our rockets. The real obstacle is our own fragility. That is why tonight we will go to the place where the equations end, to the place where the human problem begins. It all starts with a number that's hard to grasp. 4.25 light years, that's about 25 trillion miles. It just sounds like a big number, because our minds have no reference to comprehend this scale. So, let's make it understandable. The fastest spacecraft humanity has ever built is Voyager 1. It was launched in 1977 and has been travelling non-stop for almost 50 years. That is why it is now the most distant object from us. Its speed is 35,000 miles per hour. That's fast enough to cross the American continent from end to end in just 5 minutes. But, despite this incredible speed, it would take Voyager 1 a full 73,000 years to reach the nearest star, Proxima Centauri. Stop for a moment and think about that number. 73,000 years. That is not a generation. That is not a civilization. That is longer than human history itself. Because anatomically, modern humans have been on the planet for about 300,000 years. If we had launched a ship at Voyager's speed on the very first day our species began, that ship would not have even completed a quarter of its journey to Proxima Centauri by now. This is not a journey. This is not travel in any sense we know. This is a completely different category of distance, a scale the human mind has never had to hold before. So, is there no way to cross this unbelievable distance? When physicists talk about really going, they don't mean ordinary acceleration. They're talking about an almost violent acceleration. They're talking about getting a vehicle to a significant fraction of the speed of light, a percentage of 300,000 kilometers per second. But there's a catch, because the equations always demand a price. Let's assume you reach 10% of the speed of light. Even that requires decades of thrust. And even at this immense speed, the journey would take a full 42 years. The real story begins with this number. 42 years. This is not a mission duration. This is a lifetime, because there is a fundamental truth that separates this journey from all other space missions. No one who has ever left Earth has gone this far without a way back. Every astronaut in history, every cosmonaut, every crew member, carried with them the one thing a team to Proxima will not have, the knowledge that returning is possible. This knowledge is not a small detail. This knowledge shapes everything. It determines how you think about risk, how you perceive the mission, how you see yourself. Because, for a Proxima crew, return is not a plan, it is only a fantasy, a team that departs at age 30. If they can make it, will reach the destination in their early 70s. That is why everyone who goes permanently in the most absolute sense of the word. This fact fundamentally changes even the astronaut selection process, because the current psychological tests were designed for people who will come home. The longest continuous spaceflight to date is Valery Polyakov's 437 days on the Mir station. This duration corresponds to just 3% of the Proxima journey. All the psychological data we have was collected from people who knew their homes were waiting for them. But for this new mission, we have no reference points. We have to build everything from scratch. Because the real question isn't who can go. There is a deeper question, a much more unsettling question. The real question is this: those people who set out, what will they have become by the time they arrive? This is why it's not just about endurance. Ni an dam dol. It's much more. Because the people you're looking for cannot be adventurers. The adventure ends too soon. They can't just be scientists either, because science alone cannot sustain a person through 40 years of isolation. The people who could undertake this journey must be a much rarer breed. People who see the act of going itself as the purpose. Those who can accept the reality of trading the only world they have ever known for something they can't even name yet, without blinking. But not just those who find this trade bearable, but those who find it necessary. Such people have always existed. Ernest Shackleton's 1914 ad for his Antarctic expedition was almost comically honest. Hazardous journey, low wages, bitter cold, long months of complete darkness, safe return, doubtful. Shackleton received over 5,000 applications for this ad, so the urge to go is within us. The real issue is whether this urge can be channeled to a star 4 light-years away, without breaking. And behind this question lies the fundamental truth where it all begins and ends. The moment that ship launches, for those inside, the world is already dead, because the first and most brutal lesson of the universe is how quickly distance erases memories, and the disappearance of the solar system happens much faster than most people expect. So fast that the crew will not even have a chance to say goodbye before they see everything they called home shrink to a single point of light, a star no different from the billions of others. This psychological break is only the first of the journey's most challenging moments, because what awaits them in the darkness outside is not just emptiness. It is the trembling, cold, and ancient silence between the stars, and that silence seems designed to slowly take over the human mind, and in the midst of this silence, the ship itself begins to turn into an enemy, because for 40 years, everything has to work perfectly. But there is a law of engineering. Everything eventually breaks, and when it breaks in a place where you cannot call for help, that is why the most dangerous object on the mission is not a meteor. It is a slow leak that you don't notice for 3 years. The Mir space station, which remained in orbit from 1986 to 2001, was a living testament to this fact. Because Mir, over time, turned into something its designers had never foreseen. It was a lesson in how, when you live inside a spacecraft long enough, the crew becomes intimate with its failures. The cosmonauts who served on Mir developed a culture of improvised repair over time. They fixed cooling systems with pipes made for other purposes. They diagnosed problems from the sounds the ventilators made. They learned to read the station, just as you learn to read a very old house. But the Mir station was in Earth's orbit. A Proxima ship would be utterly alone. The hull of this ship must be both more robust and more flexible than anything we have ever built. Because when you reach a fraction of the speed of light, the interstellar medium is no longer that gentle nothingness. At just 1% of light speed, a grain of sand carries the kinetic energy of a small explosive device. But when you get to 10%, the numbers become much more terrifying. That's why the ship's front shield would likely have to be composed of meters-thick water, polyethylene, or composite material, and this shield must continuously absorb these impacts for decades. Behind this shield, the crew will live. The life support systems must function for a full 42 years, with no possibility of resupply. Every filter, every pump, every gasket, every valve, everything, all of it must either last for this duration or be repairable with materials on board. For comparison, the International Space Station receives a resupply mission every few months. A Proxima crew will receive none. 0. That is why water recycling has to work. Air purifiers have to work. Food production has to work. The ship's nuclear reactor has to work flawlessly for 4 decades. This is the most difficult engineering problem of the mission. Not the propulsion system, not the shield. It is the fact that every system under conditions no man-made machine has ever faced on a timescale never demanded of any man-made machine must be reliable with zero external support. Because those systems will inevitably fail, this is not pessimism. This is engineering. This is why the crew, slain over 40 years, transforms into a miniature civilization. The knowledge of how the ship works, its strange failures, the workarounds, these are not written in a manual. This knowledge lives inside the people. But if those people are lost, the knowledge is lost with them. This is why the psychology of the transit is not a secondary concern. It is silently the most important engineering specification of the mission. Because long before the physical structure fails, the minds will begin to crumble. This collapse begins with the disappearance of the solar system, and it happens much faster than you think. In July 2015, the New Horizons spacecraft reached Pluto after a 9-year journey. The science team watched for nearly a decade as Pluto evolved from a faint smudge to a dot, then a disk, then a world. But for a ship traveling at 10% of the speed of light, losing the sun would be even faster than that. Within a few days, Earth would become invisible to the naked eye. Within a few weeks, the other planets would disappear. Within 6 months, perhaps even less, the sun itself would shrink to a point indistinguishable from other stars. Yes, still the brightest point in the sky. But just a point, no longer a disk, no warmth felt on a porthole window. Just a star among the receding stars. This is the moment that mission planners debate with special care. Because the psychological break it represents is not gradual. The crew doesn't slowly detach from home. They watch home become indistinguishable from the background, and that is something else entirely. There are roughly 400 billion stars in the Milky Way. From the first year of the journey onward, the sun is just one of them. This is why the felt experience of home, the bodily sense of place, is severed cleanly and early. So what is left? What is left is not the kind of space we usually imagine. There is no landscape. There is no scenery passing by. There is only the hull of the ship, the recycled air, the faces of the people you cross the threshold with, and the absolute emptiness outside. Imagine that void between the stars. The darkness here is not the darkness of a room with the lights off. The darkness here is the darkness of a place where photons travel for years without touching anything. A place where a speck of dust can drift in one direction for 1,000,000 years, because no force deigns to alter its course. And the silence. The silence here is not a silence you can describe with sound. This is the silence of a place that has never heard a sound before, and the ship passes through this ancient and still void, patient and small, carrying its own little bubble of internal warmth through the in-between. That's why even the word travel is not quite right. Because travel implies a road, or at least a medium, water, air, a land surface, something that registers your passage. But the space between the stars registers nothing. You don't pass through it, so much as you pass over it. Like a number moving along a number line without friction, without a surface to push against. This matters for physics. But it matters even more for the human mind. We've understood all these concepts, the ship's engineering, the journey's psychology, and the nature of the void. But they all raise a single question. Is all this effort, this sacrifice, this risk, worth it? Is the place we're going, the Proxima Centauri system, a reward waiting for us at the end of this hellish journey, or is it the universe's final, cruel joke? Because when we look at the actual findings, we realize the destination is not a paradise. It may not even be a home. In fact, Proxima Centauri and that mysterious planet in its orbit might be the last place you'd ever want to go. And now comes the real shock. Because the reward waiting at the end of that unimaginable 42-year journey is not a beacon of hope. It is a warning. Proxima Centauri is not a star you would choose. In fact, it's a complete nightmare. And when astronomer Guillermo Escudé and his team announced in August 2016 that they had found a planet in its orbit, humanity's greatest dream began to turn into its greatest disappointment. Because that planet, Proxima b, might be hell itself. The first shock is the star itself. Proxima Centauri is a host it should not be. It is a red dwarf. The name might sound cute, but the reality is the exact opposite. It is tiny, only 1/8 the mass of our Sun, and it's very dim. It emits less than 1/5 of 1% of the light our Sun produces, so less than 0.2%. What does this mean? It means that to get any life-giving warmth from it, you have to get incredibly close. But that's not the main problem. Because Proxima Centauri is also an active star, and it's active in the worst possible way. It is a flare star. This means it suddenly erupts with massive bursts of radiation and charged particles. Some of these flares are hundreds of times more intense than the most powerful flares our Sun produces. This is not a star. This is a cosmic shotgun, firing continuously, and the ship you've been traveling on for 42 years is heading directly toward the barrel of that gun. So what awaits you when you arrive is not golden light. What awaits you is the wrath of a furious, small, red god. But that's just the beginning. The second shock is the planet itself. Proxima b, it's in an orbit where it shouldn't exist. Because to get a sip of warmth from that flaring star, it has to orbit at a deadly distance. The numbers are terrifying. The planet is about 4.5 million miles from its star. That might not mean much to you, so let's put it this way. That's only 5% of the Earth's distance from the Sun. It's practically scraping against the star. That's why its year lasts only 11 Earth days. It completes an entire orbit in just 11 days. That is an incredible speed, a dizzying proximity. But this proximity has a physical price. Because, at this distance, the planet is caught in the star's gravitational lock. It can no longer spin freely. Just as the Moon always shows the same face to the Earth, Proxima b must always show the same face to its star. It is a gravitationally shackled prisoner. This condition is called tidal locking. And this lock transforms the planet from a habitable world into a monster split between two extremes. And now comes the real nightmare, the third shock, the planet's surface. It's not a world. It is the union of two hells. Because, due to tidal locking, one side permanently faces the star, an eternal day. The other side is permanently in darkness, an eternal night. The day side is a scorching hell. The night side is a freezing tomb. So what about life? Perhaps it could exist in the narrow strip between the two, the Terminator line, that band of perpetual twilight. It's the only place where temperatures might be suitable for liquid water. But there's a problem. Remember that flaring star? Those constantly erupting radiation storms? A planet orbiting as close as Proxima b Olram is constantly bathed in this energy, for billions of years. So, even if the planet has an atmosphere, it is constantly being blasted into space by the stellar wind and flares, slowly stripped away, so there might not even be a sky there, just the star, a vacuum, and radiation that brings a long, slow death. This is the prize at the end of the 42-year journey, a lump of rock, scorched on one side, frozen on the other, constantly bombarded, its atmosphere stripped away. So is it all over? Is there no hope? A red dwarf, a deadly orbit, a world washed in radiation. When these terrible truths come together, does this impossible 42-year journey turn into a completely meaningless suicide mission? Because the data tells us this place is a grave. Physics screams that it does not permit life. But within that same data lies an unimaginable possibility, a sliver of hope hidden in the deepest recesses of the equations, invisible to the naked eye. Because, despite all this hostility, Proxima b has something even our Earth doesn't have, and this single truth, this single advantage, could be powerful enough to change everything, absolutely everything. Because the greatest secret of that hell planet is its age and the potential hidden within that age. Because Proxima b has been around for much longer than Earth, it is much older, and that changes everything. Despite all its hostility, It may have used time itself as a shield. If life somehow began there and was then destroyed by that merciless radiation, its traces should still be in the rocks. But there's an even more exciting possibility. What if life began and found a way? What if it retreated deep underground, into warm chemical pockets, shielded from that radiation? Maybe it's still there. This is why we don't know. The data we have is not enough to draw a conclusion. But a crew that crossed that darkness for 42 years would find out. Not from orbit, not from a telescope, from the surface, or close enough to know the truth. This uncertainty, this impossible hope, is part of what makes the journey worth imagining, and the journey itself begins long before arrival, in the deepest recesses of the human mind. That's why the real question isn't who goes, but who can remain. Because the mind has to stay sane inside that metal can for 40 years, and we know almost nothing about this. Research on the psychology of long-duration spaceflight is very thin. Because the existing data was collected from people who knew they were coming home. They had a finish line. A Proxima crew has none. That's why crew members returning home after a 6-month mission experience a disorientation that lasts for months. Not of the body, but of the mind. But for a Proxima crew, the 6-month mark is not an end point. It is just the beginning of the 7th month. This is why NASA's research on long-duration ISS crews has consistently found measurable changes in cognitive performance, mood regulation, and the texture of interpersonal dynamics after 300 days of confinement. But the Proxima transit is not 300 days. It is approximately 15,000 days. This is an entirely different psychological universe. But there is something else in that data, a sliver of hope that mission planners cling to. At a certain point in a long-duration mission, the station stops being a vehicle and becomes a home. The crew stops being passengers and become residents. The psychology shifts from enduring to living. This is the real unknown. Whether this shift can sustain itself over 40 years, over a generational timescale, through the deaths of some crew members and perhaps the births of others, this has never been tested. Because the ship has to endure, and so do the people inside. This is why psychologists use a term called the third quarter phenomenon. This is the motivational slump that tends to emerge about 2/3 of the way through an isolated mission. Energy drops, morale weakens, the crew turns inward, the finish line, which once felt close enough, has not yet arrived. But the distance behind them is so vast it creates a kind of vertigo. They are, as someone once described it, equidistant from everything. The third quarter phenomenon on a Proxima mission would emerge around the 28th year, and they would still have over a decade of travel ahead of them, and that is when the relationships between people are put to the ultimate test. Astronauts who have been on long-duration missions, like Jack Fisher and Peggy Whitson, have described a special quality that such teams develop, a kind of high-tuned awareness of the people around them. Small signals become big signals. A tone of voice carries far more meaning than it used to. The emotional weather of the ship becomes, after a while, the only weather you know. This can be a resource, a team that can read each other. This clearly can manage conflict before it escalates. But it can also be a pressure. There is nowhere to go. There is no door you can walk out of. There is no evening walk you can take by yourself. The same faces every day for 40 years. It is at this point that human relationships sail into the unknown. Because people change. They change at different rates and in different directions. A person you set out with at age 32, whom you thought you understood well, might be someone you understand less at age 50. They might be someone you have to learn all over again at 60, and by the end of the journey, they may have diverged so far from their initial selves that the distance between you becomes almost geographical. All this data, all these psychological challenges, show that the ship and crew must remain a single unit for 40 years. But the journey becomes even more brutal as it nears its destination. Because our arrival is not a moment. Arrival is a years-long, violent, and dangerous process of deceleration. And that process might be even more frightening than the journey itself. Because the universe will play its final card to take everything away from you. just when you are so close to the goal. But how does it work? This entire journey, this impossible transit, with what technology could it be possible? What is the cold, hard engineering behind the fast-paced discoveries and psychological nightmares? Let's shift gears now. Let's set the excitement aside and go down to the engine room. Because what will carry this ship to the stars is not dreams, but physics. And at the heart of this physics lies an almost unread paper, born on the desk of a man named Robert Forward in 1984. That paper did not design a rocket. It proposed something far more elegant, far more audacious. A sail. This is not a metaphor for a sailing ship. This is a real sail. But a sail pushed not by wind, but by light. This concept is called a light sail. The idea is surprisingly simple. Light, photons, although massless, have momentum. Like billions of tiny billiard balls hitting a surface, they exert a tiny push when they strike a reflective surface. This push alone is almost zero. But in the frictionless vacuum of space, when these tiny pushes are applied continuously, you can reach unimaginable speeds over time. This is what Robert Forward described in his equations. A massive laser array deployed on Earth or in orbit would focus on this thin, mirror-like sail. The intense beam of the laser would push the sail continuously, for weeks, for months. This is not like a drag racer's launch. This is more like a marathon runner's slow but steady start. But the speed reached at the end of this marathon would be tens of thousands of kilometers per second. This is why speeds like 10% or 20% of the speed of light become theoretically possible. Because your propulsion source, that massive laser, is not on the ship. It stays behind, at home. The ship doesn't have to carry the weight of its fuel, it only carries its sail and the small, precious life it holds. This is an escape from the tyranny of the rocket equation. But this freedom comes at a price. Because the energy required for this system to work is of an unimaginable scale. Consider the Breakthrough Starshot project, which aims for 20% of the speed of light. That speed is about 134 million miles per hour. We're not talking about a chip-sized probe of just a few grams, but a ship carrying people, water, food, air, everything needed for decades. To accelerate such a ship to 20% of the speed of light, the energy required would exceed the entire annual electricity production of the United States by several thousand times. This is not a rounding error. This is a statement about the kind of civilization that would need to exist for such a mission to be possible. That's why physics doesn't say impossible. Physics rarely says impossible. But what it says in this case is an extraordinary cost, not just in energy, in time, in will, and in the long, sustained commitment of a species that has never shown much long-term commitment to anything. But here's what makes it strange. Physics also says, once you reach that speed, almost nothing can stop you. Because the vacuum of space is not passive, it pushes back slightly, in the language of ionizing radiation. This means the ship must have a shield, and that shield must always face forward. Because the radiation comes from the direction of travel, this means the shape of the ship is constrained by physics before a single engineer even starts drawing. A narrow front, a thick forward shield. The universe has already designed part of the ship, so what's behind that shield? There lies the greatest and most unsolved engineering challenge of the journey, the closed-loop life support system. This is a system that has no luxury of making a single mistake for 42 years. The International Space Station is a system that operates within Earth's protective magnetic field, with constant resupply. But a Proxima ship has none of these luxuries. That's why every single part of the system must operate with near-perfect efficiency for decades. Take water recycling. The systems on the ISS can recover about 98% of the water from urine and humidity. That's a great rate. But a 2% loss means tons of water on a 40-year mission. That's why the Proxima ship system must operate at better than 99.9%. There must be almost no loss. Because every single drop of water is life. Similarly, the air purification systems, they must continuously remove the carbon dioxide exhaled by the crew from the air and convert it back into oxygen. This is usually done with chemical processes like the Sabatier reaction or by using algae bioreactors. But the filters, catalysts, and pumps of these systems must last for decades. When they break, it must be possible to produce new ones with the 3D printers and raw materials on board. Because no help is coming from the outside. Ever. And then there's food. One of the biggest unknowns. You can't take 40 years worth of canned food. That's why the ship must produce its own food. Hydroponic systems, soilless agriculture, seem like the most likely solution. Plants grown in nutrient-rich water under LED lights. But this means creating a miniature ecosystem in itself. You have to control nutrient levels, pH balance, diseases. A single plant disease could wipe out the entire food supply. That's why diversity is essential. Not just lettuce and soybeans, potatoes, wheat, various vegetables, for both nutrition and psychological health. But all these systems depend on one thing, energy, and that energy would likely come from a small nuclear reactor at the heart of the ship. This reactor must provide continuous, reliable, and maintenance-free power for 40 years. Because if it stops, everything stops. Water, air, food, warmth, everything. That is why these systems must not just be engineering marvels. They must be almost like biological entities, self-repairing, adaptable, resilient. Because there is only one certainty on a 40-year journey: something will go wrong. And when that moment comes, the crew will be left with only their own knowledge, the tools on board, and how forgiving these systems are. But alongside all this incredible technology, there is also the problem of slowing down. As hard as it is to speed up, it's just as hard to slow down. Maybe harder. Because arrival is not like docking at a port. It's like trying to catch a bullet in midair, and a single mistake you make means that at the end of a 42-year journey, everything turns into a fireball. That is why arrival is actually the most complex and dangerous phase of the journey. Because a ship moving at 10% of the speed of light, 30,000 kilometers per second, would shoot through the Proxima Centauri system like a bullet in just a few hours if it doesn't break. Slowing down requires as much, if not more, energy than speeding up. The brutal tyranny of the rocket equation confronts us again here. You need to carry a massive amount of fuel with you to slow down. But this exponentially increases the ship's initial mass, making acceleration almost impossible. It's a vicious cycle. So what is the solution? The answer, again, may be hidden in Robert Forward's paper, using the sail in reverse. Just as a ship slows down by sailing against the wind, an interstellar ship can use the star's own light and stellar wind as a brake. Years before arrival, that giant light sail is unfurled again. But this time its purpose is not to accelerate. Its purpose is to catch the photons and particles coming from Proxima Centauri. This is an incredibly slow process, a delicate deceleration that takes years. But it is the most elegant solution, because you don't need to carry tons of braking fuel with you, but there are other, more aggressive methods. The magnetic sail or magnetosail is one of them. This is a system that creates a massive magnetic field around the ship. Just as Earth's magnetic field protects us from the solar wind, this artificial magnetic field captures the charged particles in the interstellar medium, protons and ions. At a significant fraction of the speed of light, these particles create enormous friction when they hit the ship. This is like sticking your hand out the window when you're driving your car at 100 kilometers per hour. The air exerts a great deal of resistance against you. The magnetic sail also uses the air of the interstellar medium to slow the ship down. This method can provide a faster deceleration than a light sail. But it also causes intense radiation and heat to build up at the front of the ship. The shield systems must therefore withstand this incredible pressure, and the most radical idea is to use a nuclear pulse propulsion system in reverse. This is the idea of slowing down with shockwaves by setting off small nuclear explosions in front of the ship. This is the fastest, but also the most dangerous and complex method. Whichever method is chosen, the result is the same. Arrival is not a momentary event. It is a years-long negotiation with physics. The crew reduces speed, The system grows, the star fills more of the sky, and that small, locked planet, that world that was a theoretical concept throughout the journey, becomes something the crew is actually approaching. And this moment of approach, that first moment when the star transforms from a point of light into a disk, is the moment the mission becomes psychologically real. In every deep space approach, there is a moment when a target changes character. It is the moment when the target ceases to be a coordinate and becomes a thing with edges, a surface, and a shadow. The New Horizons team waited 9 full years for Pluto to make this transition. In the summer of 2015, when that heart-shaped plane finally emerged from the blur of pixels, a sound was heard in the room. Not a shout, something quieter than that. The involuntary sound people make when they have held something in their minds for a very long time and watch it finally become tangible. A Proxima crew would have waited 42 full years for that moment. In the final year of approach, Proxima Centauri would be a visible disk, faint, reddish, noticeably dimmer than the Sun in the first months of the journey. That planet in its 11-day orbit would become resolvable by the ship's telescopes, and that is when the crew would begin their real work. Detailed observations, measuring the composition of the atmosphere, if any, mapping the surface temperature gradient, looking for signs of liquid water or biochemistry in the spectral data. The purpose of a whole lifetime's journey would be realized in those last few months. In the midst of all these technical and scientific processes, the crew would cross an as yet unnamed threshold, that point where it becomes undeniable that they are no longer on the way, no longer in the in-between, but are in a place. The starlight falling on the ship's hull would be faint, reddish, and very old. It had been on its way for 4¼ years just to reach the nearest edge of the solar system they had just left, and now it was coming from a place they were finally approaching. Imagine the light here. It is different from the light you know, not harsh and white-yellow, not the kind of light that casts sharp shadows and warms the skin. This light is older, slower, a deep amber, almost rust-coloured, cooler, dimmer, and filtered through the special chemistry of a star that has been burning more patiently than the one you were born under. The planet below hangs in this light, half in shadow. The day side is a pale mustard and orange. The surface catches that warmed, dim glow. The night side is plunged into absolute blackness, the kind of blackness uninterrupted by any moon, city, or fire. And on the edge between them, that long, slow twilight zone. There, something catches the light differently. A haze, maybe a thin atmosphere, or bare rock. It's not clear yet. The star hangs lower in the sky than you would expect. It's large, but soft. Its edges are slightly blurred by whatever is left of the atmosphere below. It doesn't feel like looking at a sun. It feels like looking at something that has been burning very quietly for a very long time, and intends to keep burning long after everything here is gone. But all these technical achievements, all these challenging physics calculations, and 42 years of human endurance serve a single ultimate moment, the moment of landing, or at least orbital insertion. Because, from that moment on, the crew are no longer just passengers. They are the first inhabitants of another star system, and that is when something that has been dormant inside the ship for 40 years awakens, the spirit of exploration. But this spirit also brings with it the greatest risk. Because the question is no longer, can we get there? The question is, what will we find when we land there, and what will happen when that thing finds us? And now comes the real miracle. Now is the moment when 40 years of silence, darkness, and waiting is broken. The technical details are over. The calculations have been made. The ship is approaching its destination. But now we reach the climax. This is where the equations end, where the human spirit is pushed to its absolute limit. Because arrival is not a celebration. It is a battle, and this battle is fought on 4 separate fronts, simultaneously, with maximum intensity. This is the final act of the Proxima mission, the moment when humanity's loneliest children face the final and most brutal test the universe has thrown at them, the moment when everything is won, or lost forever. It begins now, the first shock, the most brutal one, the psychological break. Let's call it the severance. It wasn't supposed to happen. The mind was not prepared for it. But it happened. Just 6 months after launch, the sun died. It ceased to be a disk. It ceased to be a warmth. It ceased to be a place. It was now a point, the brightest point in the sky. But just a point. Just one of the 400 billion stars in the Milky Way. This moment was not gradual. It was a severance. Clean. Brutal. Suddenly, there was no such thing as home. There was only a coordinate, a memory you could look at with a telescope. The crew hadn't even completed 1% of their 42-year journey. But they had already lost their home. Forever. There were 41.5 years left, and outside, only darkness, and inside the ship, the ghost of home. This was the beginning of the longest period of mourning in history. A funeral that would last 40 years, every day with the same faces, the same recycled air, in the deepest graveyard of the universe. The scientists had predicted it. But, on paper, the reality was more terrifying than all the theories. Because, in that moment, they understood that the real journey was not to the star. The real journey was into that bottomless void within the mind, and getting lost in that void was far easier than dying in a supernova. The second shock, the physical assault, the moment they realized that what they thought was empty space was an enemy. Let's call it the bombardment. The void was not empty. It had never been empty. This was the universe's greatest lie. 1 hydrogen atom per cubic meter. On Earth, that's nothing. But at 10% of the speed of a light, 30,000 kilometers per second, that is not nothing. That is a weapon. Those stationary protons transform into high-energy particles in the ship's frame of reference. This is a flood of radiation. Constant. Merciless. Ionizing. The ship's front shield must withstand this cosmic shrapnel rain for decades. And not just protons, dust grains, micrometeoroids. At 1% of light speed, a grain of sand carries the kinetic energy of a small bomb. But at 10%, the numbers turn into a nightmare. Every single impact creates a miniature explosion on the surface of the shield. Billions. Billions. For 42 years. This is not a journey. This is like speeding through a battlefield for 40 years. The ship is not just a vehicle. It is armor, and the crew is the fragile flesh and bone inside that armor. At any moment, a single microscopic hole in that armor means the end of everything. The air leaks out, the pressure drops, and the void floods in. That is why the engineers didn't design the ship. The universe designed it. A narrow front, a shield meters thick. Because physics said that this was the only way to survive. But physics didn't say how long the shield would last. That was the greatest unknown. The third shock, the mental collapse. The moment when everything lost its meaning. Let's call it the vertigo. Year 28. 2/3 of the mission is complete. The finish line is no longer a dream. But it is still 14 years away. 14 long years. And the distance behind them, a 28-year void. That's when it hits. The third quarter phenomenon. But this is not a morale slump like on the ISS. This is an existential vertigo. The crew no longer belongs anywhere. Earth is a memory. Proxima is a target. They are in between, right in the middle. They are equidistant from everything. And this is not something the human mind can handle. Energy hits rock bottom. Fights break out. People withdraw into themselves. That face you've seen every day for 28 years suddenly becomes a stranger. Even an enemy. Because there is nowhere to go, nowhere to escape. Every little anger, every little frustration, accumulated over 28 years, surfaces in that moment. The inside of the ship becomes a pressure cooker, and there is no external help to prevent that pot from exploding. Therapists, artificial intelligence, yes, all planned. But none of them can fill the deep void created by 28 years of isolation and meaninglessness. In that moment, the crew realizes that the real enemy is not the void outside. The real enemy is the void inside their own heads, and that enemy is stronger than anyone on the ship, this is the most critical moment of the survival battle. Because, even if the ship is perfect, if the people inside break, the mission is over. The fourth shock, the arrival. And finding hell. Let's call it the disappointment. 42 years, a lifetime, lived for that moment. The first clear data from the Proxima system, and that data shows not a dream, but a nightmare. The planet, Proxima b, is a graveyard. The star is a murderer. It is a red dwarf, constantly flaring, emitting flares hundreds of times more powerful than the sun. And the planet? It's sitting at the barrel of this killer, locked by gravity, one side perpetually burning, the other perpetually freezing. And that narrow band of life? It's also constantly bombarded with radiation, for billions of years, its atmosphere long since stripped away, its surface barren. This is not a prize. This is a punishment. The place they arrived at after a 42-year journey is not a habitable world. It is the universe's do not enter sign. Humanity's greatest achievement turns into its greatest fiasco. In that moment, every single scientist, every single engineer on that ship, realizes they have wasted their lives. Hope dies in that moment. Only one question remains: what do we do? They cannot go back. They cannot stay there. For 42 years they were locked on a target. But just now that target is nothing, this is not the moment the mission ends. This is the moment the mission truly begins. Because the goal is no longer to survive. The goal is to find a meaning. On that barren rock and under that angry star, to redefine what it means to be human. But the universe has one last test prepared for them, perhaps the most difficult, the deceleration maneuver. Because, before they can land in that hell, they have to avoid shooting past it like a bullet. And this is the final and most deadly puzzle physics has presented them. And this puzzle has only one wrong answer: extinction. So how will they achieve this impossible breaking? And what will be the real surprise waiting for them after billions of years of silence when they land on that barren world? Because the biggest shock has not yet arrived. This is why the biggest shock had not yet arrived. Because, as they approached that barren, seemingly dead planet, the ship's sensors detected an anomaly, something that shouldn't be there, a signal. But it wasn't a radio signal, nor was it a natural emission. It was a periodic, regular, and seemingly artificial fluctuation in the planet's magnetic field. It was impossible. Because Proxima b shouldn't have a magnetic field strong enough to protect its atmosphere, which was constantly being battered by that stellar wind. But it was there. Weak, but it had a structural pattern. This was the greatest discovery in history. The first proof of non-human intelligence. They had passed through that hell for 42 years, and what they found when they arrived was not an empty rock. They found someone's home, and those someones must have been living there for billions of years, deep down, underground, protected from those radiation storms. They were using the planet's weak magnetic field, perhaps amplifying it with their own technology, as a shield. This discovery shattered all of Earth's scientific paradigms in that instant. We were no longer alone. This was a fact. But this fact also brought a question. Were these beings friendly? Or would they see these uninvited guests from 4.25 light-years away as a threat? The crew were no longer explorers. They were the first diplomats in human history. And the smallest mistake they made could be the end not only of themselves, but of the entire species they left behind. But there was a bigger shock. The second epic moment. It was about time itself. Because when the ship reached 10% of the speed of light, the equations of special relativity kicked in. Time, inside the ship, began to flow more slowly relative to Earth. This effect was very small at this speed, almost imperceptible. Mission planners had calculated this. At the end of the 42-year journey, the crew would be only a few months younger than they would have been on Earth, a negligible difference. But they hadn't accounted for one thing: the intense gravitational fluctuations in the interstellar medium. As the ship passed near massive, previously unmapped filaments of dark matter, unexpected, tiny but measurable deviations occurred in the flow of time. the ship's atomic clocks began to lose synchronization with the reference clocks on Earth. Just seconds. Then minutes. By the 20th year, the difference was hours. By the 40th year, it was days. When they arrived, there was a nearly 3-week difference between the crew's calendar and Earth's calendar. This was impossible. Current physics models did not predict such a large time dilation. This meant that our understanding of gravity and dark matter might be fundamentally wrong. The crew had not only gotten lost in space, but in time. They didn't just discover a new continent for humanity. They discovered that time itself was an unknown ocean. This discovery didn't demolish Einstein's theories. But it left them incomplete. It showed that the universe has a much stranger, much more flexible temporal fabric than we thought. And within this fabric, perhaps, other, faster ways of travel were hidden, particles in the ship's frame of reference. This is a flood of radiation. Constant. Merciless. Ionizing. The ship's front shield must withstand this cosmic shrapnel rain for decades. And not just protons, dust grains, micrometeoroids. At 1% of light speed, a grain of sand carries the kinetic energy of a small bomb. But at 10%, the numbers turn into a nightmare. Every single impact creates a miniature explosion on the surface of the shield. Billions. Billions. For 42 years. This is not a journey. This is like speeding through a battlefield for 40 years. The ship is not just a vehicle. It is armor, and the crew is the fragile flesh and bone inside that armor. At any moment, a single microscopic hole in that armor means the end of everything. The air leaks out, the pressure drops, and the void floods in. That is why the engineers didn't design the ship. The universe designed it. A narrow front, a shield meters thick. Because physics said that this was the only way to survive. But physics didn't say how long the shield would last. That was the greatest unknown. The third shock, the mental collapse. The moment when everything lost its meaning. Let's call it the vertigo. Year 28. 2/3 of the mission is complete. The finish line is no longer a dream. But it is still 14 years away. 14 long years. And the distance behind them, a 28-year void. That's when it hits. The third quarter phenomenon. But this is not a morale slump like on the ISS. This is an existential vertigo. The crew no longer belongs anywhere. Earth is a memory. Proxima is a target. They are in between, right in the middle. They are equidistant from everything. And this is not something the human mind can handle. Energy hits rock bottom. Fights break out. People withdraw into themselves. That face you've seen every day for 28 years suddenly becomes a stranger. Even an enemy. Because there is nowhere to go, nowhere to escape. Every little anger, every little frustration, accumulated over 28 years, surfaces in that moment. The inside of the ship becomes a pressure cooker, and there is no external help to prevent that pot from exploding. Therapists, artificial intelligence, yes, all planned. But none of them can fill the deep void created by 28 years of isolation and meaninglessness. In that moment, the crew realizes that the real enemy is not the void outside. The real enemy is the void inside their own heads, and that enemy is stronger than anyone on the ship. This is the most critical moment of the survival battle. Because, even if the ship is perfect, if the people inside break, the mission is over. The fourth shock, the arrival. And finding hell. Let's call it the disappointment. 42 years, a lifetime, lived for that moment. The first clear data from the Proxima system, and that data shows not a dream, but a nightmare. The planet, Proxima b, is a graveyard. The star is a murderer. It is a red dwarf, constantly flaring, emitting flares hundreds of times more powerful than the sun. And the planet? It's sitting at the barrel of this killer, locked by gravity, one side perpetually burning, the other perpetually freezing. And that narrow band of life? It's also constantly bombarded with radiation. For billions of years, its atmosphere long since stripped away, its surface barren. This is not a prize. This is a punishment. The place they arrived at after a 42-year journey is not a habitable world. It is the universe's do not enter sign. Humanity's greatest achievement turns into its greatest fiasco. In that moment, every single scientist, every single engineer on that ship realizes they have wasted their lives. Hope dies in that moment. Only one question remains: what do we do? They cannot go back. They cannot stay there. For 42 years they were locked on a target. But just now that target is nothing, this is not the moment the mission ends. This is the moment the mission truly begins. Because the goal is no longer to survive. The goal is to find a meaning on that barren rock and under that angry star, to redefine what it means to be human. But the universe has one last test prepared for them, perhaps the most difficult, the deceleration maneuver. Because, before they can land in that hell, they have to avoid shooting past it like a bullet. And this is the final and most deadly puzzle physics has presented them. And this puzzle has only one wrong answer: extinction. So how will they achieve this impossible breaking? And what will be the real surprise waiting for them after billions of years of silence when they land on that barren world? Because the biggest shock has not yet arrived. This is why the biggest shock had not yet arrived. Because, as they approached that barren, seemingly dead planet, the ship's sensors detected an anomaly, something that shouldn't be there, a signal. But it wasn't a radio signal, nor was it a natural emission. It was a periodic, regular, and seemingly artificial fluctuation in the planet's magnetic field. It was impossible. Because Proxima b shouldn't have a magnetic field strong enough to protect its atmosphere, which was constantly being battered by that stellar wind. But it was there. Weak, but it had a structural pattern. This was the greatest discovery in history. The first proof of non-human intelligence. They had passed through that hell for 42 years, and what they found when they arrived was not an empty rock. They found someone's home, and those someones must have been living there for billions of years, deep down, underground, protected from those radiation storms. They were using the planet's weak magnetic field, perhaps amplifying it with their own technology, as a shield. This discovery shattered all of Earth's scientific paradigms in that instant. We were no longer alone. This was a fact. But this fact also brought a question. Were these beings friendly? Or would they see these uninvited guests from 4.25 light-years away as a threat? The crew were no longer explorers. They were the first diplomats in human history. And the smallest mistake they made could be the end not only of themselves, but of the entire species they left behind. But there was a bigger shock. The second epic moment. It was about time itself. Because when the ship reached 10% of the speed of light, the equations of special relativity kicked in. Time, inside the ship, began to flow more slowly relative to Earth. This effect was very small at this speed, almost imperceptible. Mission planners had calculated this. At the end of the 42-year journey, the crew would be only a few months younger than they would have been on Earth, a negligible difference. But they hadn't accounted for one thing: the intense gravitational fluctuations in the interstellar medium. As the ship passed near massive, previously unmapped filaments of dark matter, unexpected, tiny but measurable deviations occurred in the flow of time. The ship's atomic clocks began to lose synchronization with the reference clocks on Earth. Just seconds, then minutes. By the 20th year, the difference was hours. By the 40th year, it was days. When they arrived, there was a nearly 3-week difference between the crew's calendar and Earth's calendar. This was impossible. Current physics models did not predict such a large time dilation. This meant that our understanding of gravity and dark matter might be fundamentally wrong. The crew had not only gotten lost in space, but in time. They didn't just discover a new continent for humanity. They discovered that time itself was an unknown ocean. This discovery didn't demolish Einstein's theories. But it left them incomplete. It showed that the universe has a much stranger, much more flexible temporal fabric than we thought. And within this fabric, perhaps, other, faster ways of travel were hidden. now, the third epic moment. It was about biology itself. Let's call it the metamorphosis. For 40 years, the crew lived in a closed ecosystem. Recycled air, recycled water, hydroponically grown food of limited variety, and a constant low-level but unceasing bombardment of radiation. Without Earth's protective atmosphere and magnetic field, their bodies had to adapt. But no one expected this adaptation to be so radical. After the 30th year, an accelerated mutation rate was observed in the crew's genetic material, their DNA. This wasn't cancer, this wasn't random degradation, this seemed to be a directed adaptation. Their bodies began to produce new proteins that made them more resistant to radiation. Their digestive systems adapted more efficiently to that monotonous diet. Even their vision, adapting to the dim, artificial light inside the ship, became more sensitive to different spectrums of light. They were no longer Homo sapiens, at least not in the sense they left behind on Earth. They were the first humans to take the next step in evolution, adapting to a new environment, Homo caelestis, celestial human. This shook the most fundamental laws of biology. Because evolution wasn't supposed to be this fast, it showed that the human genome has a hidden potential for adaptation, activated under extreme stress conditions that we never knew existed. The crew didn't just reach another world, they themselves became another species, and this separated them forever from the humanity they left behind. All these shattering discoveries, these revolutions in physics and biology, pointed to one great truth. The journey had changed the crew before they changed their destination. They set out at 32, people who knew only one world and had not spent a single night beyond gravity's pull. But the ones who arrived were not those people, not because of the hardships. Yes, there were hardships. But because the very texture of living for 40 years, truly living, with all its loss and harmony, changes a person in a way no other experience can. They arrived as something new, not post-human in the science fiction sense, not transformed, just changed. As any human is changed by a life spent doing something that matters. The destination was strange, perhaps uninhabitable, almost certainly not the world they had hoped for. But they had made it. And the universe, that universe which notices most things not at all, had been witnessed from a vantage point no human had ever reached before. This was not a small thing. But now it's time to stop and think. All these discoveries, these broken paradigms, this new form of humanity, what does it all mean for us, for those of us left here? Because their journey was not just about covering a distance in space. Their journey was about rewriting the definition of what it means to be human, and facing the consequences of that new definition might be the hardest journey of all. But now it is time to stop and think. The speed is gone, the shock is over, the epic moments are behind us. Now we face the most important question. What does all this mean for us? For those of us living on this spinning, water-covered world, in the specific warmth of this specific night. Because if this journey has taught us anything about the universe, it is a deep, unsettling, and yet strangely comforting paradox about our place in it. Understanding this paradox is perhaps more important than going to the stars. Because it means understanding who we are, and that is the longest journey of all. The first contrast is time itself. On one hand, there is Proxima Centauri. It has been burning for about 4.5 billion years. It is older than Earth. It is older than our Sun. It formed in the early youth of this part of the galaxy, from a cloud of gas and dust that has now completely dispersed, and it has been burning quietly ever since. As a red dwarf, it will continue to burn for trillions of years. This is a very, very long time, much longer than the current age of the universe. 4 trillion years from now, when our own sun has long since expanded to swallow the inner planets and shrunk into a quiet white dwarf, Proxima Centauri will still be burning, colder perhaps, dimmer perhaps, but burning. This is the time scale of the universe, near infinite, just, patient, and indifferent. On the other hand, there is us, our entire civilization, every century of recorded history, every monument built, every signal sent, every spacecraft launched. All of this is less than a breath on that vast timescale. Our fastest spacecraft, if it had travelled at full speed for the entire duration of human history, would not have even left the solar system yet. This is our tragic truth. We are a cosmic blink, here for a moment and then gone. In the grand symphony of the universe, we are just a fleeting, barely audible note. This truth can make us feel insignificant, like nothing. But that but changes everything. But within that fleeting moment, we can look at the universe. We can understand the existence of that 4.5 billion-year-old star. We can calculate that it will burn for trillions more years. We are the universe's way of thinking about itself. That fleeting breath might be the only moment the universe gives meaning to itself. And you are at the very centre of this incredible paradox. Your 80-year life within a 13.8 billion-year-old universe. But during those 80 years, you can hold that vast time in your mind. You can see the light from Proxima Centauri that started its journey 4 years before you were born. You're a being that speaks with time itself. This does not make you insignificant. This makes you a miracle. The second contrast is distance itself. On one hand, there is that unimaginable void between the stars, 25 trillion miles. This is a distance the human mind cannot truly grasp. If each mile were a second, it would take about 800,000 years to count the distance to Proxima Centauri. This void is absolute loneliness, a place where photons travel for years without touching anything, a place where a speck of dust drifts for 1 million years. This is the fundamental state of the universe, separation. Everything is incredibly far from everything else. Our sun is a tiny island of warmth in that void, and we are beings living on that island surrounded by a cosmic ocean. This is our tragic truth. We are alone, incredibly, almost unbearably alone. Even our nearest neighbour is tens of thousands of years away with our fastest ships. This is a kind of prison. But that but changes everything again. But despite that unimaginable distance, we can write a letter into that void. When Robert Forward finished that paper in 1984, that's exactly what he was doing. He wasn't designing a spaceship, he was designing a letter sent into the darkness, knowing that an answer would not come within his lifetime, knowing that those who launched it might not see it arrive, and you're a part of that letter. Tonight, as you read or listen to these words, you too are crossing that 25 trillion mile distance in your mind. You too are imagining that ship. You're thinking of that crew. Distance may separate us physically, but it cannot separate our minds, our imagination, our curiosity. We are the species that fills distance with meaning, and this connects us with the strongest bonds in the universe. Because we are all looking at the same ocean from the same shore. The third contrast is knowledge itself. On one hand, there are the things we know, the laws of physics, the rules of chemistry. That brilliant thesis Cecilia Payne-Gaposchkin wrote in 1925, the moment she discovered that stars are mostly made of hydrogen. At the time, it was a radical idea. But now, it's a fundamental truth. We know the universe has a grammar, rules we can understand, calculate, and predict. This knowledge gives us a sense of power. We believe that even if we can't control the universe, we can understand it. But, on the other hand, there are the things we don't know, and that is a much larger ocean. What is on the surface of Proxima b? We don't know. Is that faint magnetic signal real? We don't know. What is the dark matter and dark energy that make up 95% of the universe? We don't know. This is our tragic truth. Our knowledge is a tiny island in an ocean of ignorance, and every wave that crashes on the shores of that island reminds us of how little we know. This can make us feel small and helpless. But that but takes the stage again. But that ignorance, that unknown, is also the journey itself. It is the fuel of curiosity. It is what gets us out of bed in the morning, makes us turn telescopes to the sky, makes us write equations. The unknown is not a curse. It is a gift. Because If everything were known, there would be nowhere left to go, and you live right in the heart of this ignorance. Every day, you walk on the border of what you know and what you don't, and that doesn't make you weak. It makes you an explorer, because every time you say, I don't know, you're actually saying, let's find out. And that is the most fundamental, most noble human impulse. If this journey has taught us anything, it is this. The answers don't matter. What truly matters is the courage to keep asking the questions. Because, in those questions, we find the secrets not only of the universe, but of ourselves. But, beyond all these philosophical thoughts, this journey has a more concrete, deeper meaning for humanity. It's not just about who we are, it's a question about what we can become, and the answer to that question could shape our future. That is why this journey reshapes our relationship with the future. Because, the moment a civilization decides to send humans to the stars, it doesn't just launch a space mission. That moment is an act that rewires the species' relationship with the future. It forces us into a kind of long-term thinking that does not come naturally. We are creatures evolved to manage seasons, harvests, and the span of a single human lifetime. But an interstellar mission fits into none of these scales. To fund, build, and launch such a mission is to make a decision whose full consequences will only become apparent 40 years after you make it. The return on information, if the crew has anything to transmit, comes 46 years after that. The people who made the decision will be old, many will be dead. The world they made the decision in will be different, and the results, whatever they are, will be received by people who were not yet born when the ship departed. This is a new relationship with time, not the time of quarterly reports, or election cycles, or even generational politics. This is the time of something that outlives everyone who started it. Herein lies the fourth contrast: action and legacy. On one hand, there is the shortness of our individual lives. We see the impact of most of the things we do with our own eyes. We build a house, we live in it. We start a company, we watch it grow. We raise a child, we see them become an adult. Our actions and their consequences usually remain within our own lifetimes. This is our natural rhythm. This is our tragic truth. We know that even the greatest things we do are tiny ripples in the ocean of time. Our legacy, after a few generations, is largely forgotten. This can create a sense of existential futility. Do our actions have any ultimate meaning? But that but changes everything once more. But we are capable of doing things we will not see completed, and this is perhaps the noblest, most hopeful quality of our species. Every cathedral built in the Middle Ages was started by someone who knew they would not see its spire finished. Every great tree planted in a city park was planted by someone who knew they would not see it reach its full height. We are capable of this. We have always been capable. When Robert Forward sat at that desk and wrote those equations, he was not designing for himself. He was designing for the people who would come after the people who would come after him. He was writing a letter to the future, knowing that the future was the only audience that mattered. And you face such a choice every day. Will you only engage in actions with immediate results? Or will you plant the seed of something that will outlive you? It could be a tree, an idea, a value you teach a child. You're not just living a life, you're also building a legacy. And an interstellar mission is this impulse, aimed at the stars. And this brings us to the final contrast: silence and witness. On one hand, there is the vast, indifferent silence of the universe. Proxima Centauri has been burning for 4.5 billion years. But it's not doing it for anyone. It's just burning. The planet in its orbit has been tracing that small ellipse for billions of years. But it's not doing it for anyone to see. It's just orbiting. The space between the stars maintains its long, cold silence. The universe does not need us. It does not expect us to exist. It does not expect us to arrive. It is complete and whole without us. This is our tragic truth. In a cosmic sense, our existence or non-existence makes no difference. This is the ultimate loneliness. On the grand stage of the universe, we are just silent extras. But, and this is perhaps the most important but, But we're here, on this world, looking at it, and this decision, this act of reaching out into that unimaginable darkness, transforms us into something new. We are the witnesses of the universe. It is we who give meaning to that silence. It is we who give a name to that star, assign a letter to that planet, measure that distance. That silent as indifferent universe comes to know itself through our consciousness. This is an unimaginable responsibility. But it is also an unimaginable privilege, and you are a part of this testimony. When you look up at the sky tonight, you're not just seeing points of light, you're seeing stories, you are seeing history, you are seeing the future. You're a pair of eyes through which the universe looks at itself, and in that silence, your testimony is the only sound the universe hears. What you choose to fill that sound with is your choice. This journey, with all its physics, engineering, and psychology, is in fact the most extreme expression of this testimony. It is a way of saying, we were here, we understood, and we wondered. So where do all these contrasts, these philosophical reflections, lead us? The shortness of time, but the potential for meaning. The greatness of distance, but the mental proximity. The vastness of ignorance, but the power of curiosity. The necessity of legacy and the privilege of bearing witness against the silence. We now know that going to the stars is not just about going from one place to another. It is about confronting the most fundamental questions of what it means to be human. But there is one more question, perhaps a deeper one than all the rest. This whole journey, all this sacrifice, all this change, does it only change those who go? Or the moment that ship is launched, do we who remain behind also change forever? Because maybe the real journey is not inside that ship. Maybe the real journey takes place in the hearts and minds of the billions of people who follow that invisible trail the ship leaves in the sky for 42 years. That is why we now face a deeper question. We understood that those who go are changed. But these thoughts lead us to another place. Because the moment that ship is launched, it's not just a handful of people who change, but an entire species. The real journey takes place in the collective consciousness of the billions of people who watch, wait, and dream as that ship progresses across the sky for 42 years. That is why now is the time to ask the most internal question. What do we do with this knowledge? How do we move from understanding to action, from silence to voice? Because us looking at the stars is not a passive act. It is a responsibility. The first contrast is silence and voice. On one hand, there is the absolute silence between the stars. This is not the silence of a place where there is no sound. This is the silence of a place where sound has never existed. That deep, ancient stillness where photons travel for millions of years without hitting anything. The fundamental state of the universe. That ship moves in that perfect silence. It makes no sound because there is no medium for sound to travel through. The hum of its reactor, the whisper of recycled air, all trapped within that metal shell. Outside, only absolute, crushing silence. This is our tragic truth. The language of the universe is silence. It does not hear us, it does not answer. It is completely indifferent to our calls, our questions, our existence. We are a species shouting into a deaf universe. But all that but breaks the silence once more. But we can make a sound. The breath of a sleeping crew member inside that ship is the most powerful defiance against that cosmic silence. The warmth inside, the light, the sounds of life. These are an act of resistance against the indifference of the universe. That ship is not just a piece of technology. It is a cathedral, carrying the triumph of life against silence. And you make this choice every day. Will you surrender to the silence of the universe and remain silent too? Or will you raise your voice by asking a question, telling a story, singing a song? You're a being that whispers a meaning into that silent universe. Your voice is as precious as the breath of the crew on that ship. Because they both say the same thing, we are here. The second contrast is the journey and the destination. On one hand, there is the incredible, arduous 42-year journey of this mission. Physical, psychological, engineering, an epic of endurance in every respect. The entire focus, all the planning, All the effort is on completing that long transit safely. The journey is the obstacle to overcome. The destination is the reward. At least, that's how it seems at first. But, if this journey has taught us anything, it is that the exact opposite is true. This is our tragic truth. The destination, Proxima, B, may be a disappointment. Barren, hostile, perhaps dead. The reward for 42 years of sacrifice might be nothing more than an empty rock. This can make us feel that all the effort was meaningless. But, and this is perhaps the deepest lesson of the entire journey, but it is not the destination that matters, it is the journey itself. Because the journey changes the crew before the destination does. What they learn, what they cope with, what they become during that 40-year process is far more valuable than any rock or trace they might find on the surface of Proxima b. They become living proof of human endurance, adaptation, and curiosity. That is why the journey itself is the destination, and you experience this truth in your own life every day. We are all running towards a goal, a diploma, a promotion, a house. But when we reach that goal, we often feel a sense of emptiness. Because what truly matters is who we become while reaching for that goal. What you learned on that path, the relationships you built in the process, the character you developed while facing those challenges, that is the real reward. You're not a passenger going to a destination. You are the journey itself. The third and final contrast is change and permanence. On one hand, there is the patient, unchanging existence of Proxima Centauri. It has been burning in the same way for 4.5 billion years. The planet in its orbit has been turning in the same orbit for 4.5 billion years. The space between the stars has been cooling and expanding in the same way for 14 billion years. The fundamental fabric of the universe is constant on a human timescale, unchanging. It was always there, and it will always be there. This is our tragic truth. All our efforts, all our wars, all our joys are just a fleeting ripple on the surface of that permanence. We are temporary. The universe is permanent. This can once again make us feel that our actions are futile. But, for the last time, that but, we can change, and that is our greatest strength. That crew changed during the journey. They transformed from Homo sapiens to Homo caelestis. We, who remained here, changed with the decision to launch that ship. Our perspective on the future, our relationship with time, our belief in ourselves as a species changed. In an unchanging universe, we are the only force that can create change. And you have this power too. Every day, you have the potential to be a different person than the day before. You can learn something new, acquire a new skill, gain a new perspective. You're not a static being. You are a process, a possibility, and under those unchanging stars, your ability to change is the most radical, most revolutionary act in the universe. Those silent, ancient stars are not waiting for us. They do not need us. But we are here, looking at them, and we decide to go. And that decision changes not just us, but perhaps the universe itself. Because on to a place that was once only silent, we now send a question, a hope, and a witness. But after all these thoughts, one final, single image remains. That ship, that small, warm, and lonely ship, as it glides through the darkness of the night, among the stars. What does it feel like to be inside that ship? What is it like to experience that silence, that loneliness, that hope in its purest form? For one last time, let's return to that ship and witness the final moments of the journey. That is why to be inside that ship is to experience the ultimate solitude. The darkness between the stars does not hurry. It extends in all directions, endless, edgeless, with no surface to reflect the light back. It holds the cold with patience, and in the middle of that darkness, the little spaceship moves. Most of the crew are asleep. In their narrow bunks, in those moments when the recycled air passes softly by them, when the hum of the ship has become as familiar as the sound of rain on a childhood window. Outside the ship, the void is very still. The hydrogen atoms drifting here have been drifting for millions of years without encountering anything. They pass by the ship without touching it. They part around the magnetic field at the bow, like smoke around a moving hand, and the ship progresses in that in-between, steady and small, carrying its own little glow through the darkness. The first and deepest contrast is between inside and outside. On one hand, there is the absolute cold outside the ship, the cold of the interstellar medium, just a few degrees above absolute zero, the temperature of a universe that has been cooling for 14 billion years, just beyond an 8-inch hull wall, the coldest cold that exists. Lethal, immediate, and unforgiving. This is our tragic truth. The default state of the universe is hostile to life. Warmth, light, and complexity are exceptional islands in that overwhelming ocean of cold and simplicity. We are an anomaly, fragile and exceedingly rare. But, and this is the most fundamental but of existence, but inside that 8-inch wall, there is warmth, there is light, there is the sound of breathing. That is all there is. But it is also everything there is. The life inside that small, man-made shell is a defiance against the vast, lifeless void outside. We may be an anomaly, but we exist, and you experience this contrast every moment. Just outside your own skin, there is a universe that could destroy you. But inside, there is a consciousness, a warmth, a heartbeat. You are like that ship. You are a fragile capsule, carrying your own little warmth through an indifferent universe, and that does not make you weak. It makes you infinitely precious. The second contrast is between fear and curiosity. On one hand, there are the unimaginable dangers of the journey to Proxima Centauri: radiation, isolation, technical failures, psychological collapse. This journey is frightening, not just because we might fail, it is also frightening because we might succeed. We could build that ship, launch the crew, wait 42 years, and finally receive a transmission from a place no human has ever been. And the people in that transmission will not be the people we sent. They will be the people those people have become, changed by time, by silence, and by the particular quality of light that falls on a rocky, uncertain world from that small red star. This unknown, this transformation, creates an instinctual fear. This is our tragic truth. We fear the unknown. We fear change. Because we fear losing control. But, that final but. But, on the other side of that fear is curiosity. The insatiable urge that makes us imagine that ship, makes us write the equations, makes us look into that 4¼ light years of darkness and say, let's go. What they will find when they get there is unknown. But what they become on the way is perhaps more interesting. And you walk between these two emotions every day, the fear of the unknown and the desire to explore it. And every time you choose curiosity, you take a step with the crew on that ship. Because curiosity is the only antidote to fear that humanity has ever found. And if this time you've spent with this star tonight has brought you something quiet, a little perspective, a little wonder, that special feeling of smallness that somehow feels like relief, then we're glad you were here. Because, at the end of the night, this is all that's left. Outside, the void stretches in all directions, cold, very old, and very still. The stars embedded in it, at enormous distances from each other. Each one burns its own silent fire. Each one is patient. The darkness between them is not empty in the sense that something is missing. It is full of nothingness. This is a different kind of fullness that keeps everything at the right distance from everything else. The ship is very small in it, and the sleeping crew just is smaller still. But that ship keeps going. It carries its little warmth forward, and the crew breathes in and breathes out. And the darkness holds them all gently. We know now that the journey to the stars is not a physics problem, it is a human problem. We know that distance is the smallest part of the equation, and we know that the journey changes the traveller before the destination does. At the end of this long night, after all the philosophical thoughts and technical details, the story returns to its simplest form, to a moment of decision. The story of a species, here on this world, that looked up and decided to go, and that decision has already transformed us into something new. Now, the journey ends. We have come to the end of this long night, and with one single image left in our minds, we return to the moment where it all began and where it all ends. We have journeyed tonight into the deep, silent void between the stars. But let me tell you a secret, that void is not silent at all. The universe has a music created when black holes collide, a whisper that ripples the very fabric of space-time, reaching us from billions of light years away. On our next journey, we will listen to this secret